So the last thing that I want to do with conic sections is just to go through how can you identify that you are looking at an equation that is one of these conic sections and which one is it. Sometimes when you're dealing with especially a larger scaled problem, it is enough to be able to identify, okay, I'm dealing with an ellipse, and now I know enough information to continue on with the problem. So we're going to start with the parabola, and I know that that wasn't something that we looked at this week, but it is a conic section, so I'm going to include it here. And if you've got a parabola, hopefully we remember enough about parabolas to know that they only have one squared term. So if I've got a parabola, I'm looking at that equation and seeing that it only has an x squared or a y squared, but it is not allowed to have both. Now the rest of these do have both. So in the hyperbola, I'm looking for an x squared and a y squared, but they have to have opposite signs. So remember that hyperbola has that negative in it. That's where that negative comes in, where it's got to have one of them negative in order to be a hyperbola. With the circle, we know that they are both positive. Again, we have an x squared and a y squared. They have the same sign, so technically if they're both negative, we could factor out the negative, and now they're both positive. So as long as they have the same sign, and then we're going to talk about this in our examples in a second, but they should have the same coefficient or the same divisor. And then our last one in the ellipse, we've got an x squared and a y squared. They do have the same sign, just like in the circle, but they're going to have a different coefficient or a different divisor. So for each one of these, we're going to classify what kind of conic section it is. You might notice that my 13 through 16 look a little more like what we've been dealing with, where we've got the x minus the number x minus h and y minus k in parentheses like that, and that's not happening on the 9 through 12, but that doesn't mean that we can't identify what kind of conic section it is. So with number 9, I'm first looking at the fact that I've got an x squared and a y squared, so it's not a parabola. They're both positive, so that means it's not a hyperbola, so I'm narrowed down to a circle or an ellipse. And then like we said earlier, if they have the same coefficient, that means that it is a circle. Basically, if they have the same coefficient, it just means that if I did move it from this form to this form down here, that I wouldn't have anything out in front of it to where I need to divide and it end up looking like this. It would end up looking something like that instead. For number 10, I've got an x squared and a y squared. I've got positive, so it's either a circle or an ellipse. But on this one, the 16 is in front of x squared. We've got a 1 in front of y squared, so this is an ellipse. Number 11, because one of my terms is negative, it is automatically going to be a hyperbola. Notice that they are both squared though, so don't be tricked by that, because in number 12, I do have one negative term and one positive, but there's only one squared term, so number 12 is a parabola. Okay, go ahead and pause the video, see if you can go ahead and label the last 4 on your own. So number 13 with just the x squared term is a parabola. 14 with the 2 different numbers below x and y, adding in between is an ellipse. Hyperbola, or number 15 is similar, but it's negative, so it's a hyperbola. And then number 16 is a circle, because if we did divide both sides, this is kind of going backwards from that number 9. If I did divide both sides by 16 to where it equaled 1, then they would both have the same divisor, but we also recognize it as having that radius squared piece.